Find the settlement from consolidation in inches from a load after 2 years. In this problem, a load of 400 pounds per square feet is applied to a soil profile consisting of a 6-foot thick layer of sand, a 20-foot thick layer of clay, and a 4-foot thick layer of gravel. We've also been provided various soil properties. In this problem, we assume the clay is the only soil type which consolidates. So we begin by solving for the ultimate consolidation in the clay layer. The height of the clay layer is 20 feet. Since the clay layer is normally consolidated, we'll use 0.40 for our consolidation index. Next, we'll solve for the initial void ratio. Since the clay layer is saturated, we know the total unit weight can be determined from the specific gravity, void ratio, and unit weight of water. After solving for the void ratio and plugging in our known values, assuming the specific gravity is 2.70, we find the initial void ratio to be 1.23. Now, all we have to do is solve for the initial and vertical effective stress values. Let's evaluate a point at the middle of the clay layer, which would be at a total depth of 16 feet. We add the overburden stress from the unsaturated sand, the saturated sand, and the top 10 feet of the clay layer. Our initial stress is 999 pounds per square feet, and after adding the load of 400 pounds per square feet, our final stress is 1,399 pounds per square feet. We update our settlement equation to find the consolidation settlement is 6.30 inches. This is the maximum consolidation settlement which would occur if the soil had an infinite amount of time to consolidate. We'll call this the ultimate consolidation. This is the consolidation which is typically referred to in consolidation settlement problems when time is not mentioned. However, in this problem, we're asked to find the consolidation settlement after 2 years. So, we already know the answers between 0 and 6.30 inches. The consolidation settlement after a certain time equals the ultimate consolidation times the percent of consolidation which has already occurred, U. We'll call this U value the average degree of consolidation, which ranges from 0 to 100%. U is a function of big T, the time factor. And the time factor is equal to the time rate of consolidation, which is sometimes called the consolidation coefficient, times the time the soil has to consolidate, divided by the drainage distance squared. The drainage distance is the furthest distance a drop of water would have to travel to exit the consolidating layer. Since our clay layer is doubly drained, the drainage distance is half the layer thickness, or 10 feet, which makes our time factor equal to 0.10. Next, we solve for our average degree of consolidation. When T is less than about 0.285, the average degree of consolidation is equal to the square root of 4 times T divided by pi, all times 100%. When T is greater than about 0.285, the average degree of consolidation is this second equation. For our problem, T equals 0.10, so we'll use the first equation to solve for U. After 2 years, this 20-foot thick clay layer has consolidated 35.7% of its ultimate consolidation settlement, or 2.25 inches of settlement. Compared with our possible solutions, the answer is A.